So the last video I want to make is about redox indicators. So in respiration, if you remember, hydrogen atoms are removed from molecules, and that process is called dehydrogenation, and it is carried out by dehydrogenase enzymes. And what happens is NAD and FAD pick up those hydrogens, but they can only do that because there have been dehydrogenase enzymes to help. So NAD and FAD become NADH and FADH because they have picked up the hydrogens. So you can add a redox indicator and it can pick up the hydrogens as well. But the wonderful thing about redox indicators is that they change colour when they pick up hydrogens. So this experiment would prove that respiring organisms do produce hydrogens. So the redox indicator that I'm going to talk about is methylene blue, which is actually blue whenever it's oxidized. So whenever the methylene blue then gains hydrogen ions from respiration, it changes into reduced methylene blue. Now remember that reduction is the gain of hydrogen. So if it gains hydrogen, it is reduced and it changes from being blue to being colourless. So here we have a typical experiment. So you take respiring peas that have been kept in the dark and you crush them and you add them to a boiling tube which contains methylene blue. So if we look just at the result for that one, so there you have your peas that have been crushed. That increases the surface area and also it will help to release the mitochondria. So in here we've got crushed peas and we've got methylene blue, which is blue, and then you just leave it for an hour, and whenever you return, it is now, the methylene blue is now colourless. Now you might see a little bit of green from the peas, but what has happened is those crushed peas have released hydrogen. Some of it's been picked up by NAD and FAD, but a lot of the hydrogen has been just picked up by the blue methylene blue, which turns colourless. Now this would be the control experiment. You take some peas and you boil them. Whenever you boil them, that will denature the dehydrogenase enzymes, and then you do exactly the same. You crush them and you add them to a boiling tube which contains oxidized methylene blue, which is blue. So whenever you do that, the methylene blue stays blue. The methylene blue does not have hydrogen added to it. And the reason for that is that the dehydrogenase enzymes that are needed to remove the hydrogen, they have been denatured. So no hydrogen is released. Respiration has stopped. No hydrogen is released. And so the oxidized methylene blue stays blue. So that's a very simple summary of redox indicators.